final method I'm going to show you for solving a system of equations is going to be called the elimination method. And what this method is going to involve is adding the two equations we have together in order to eliminate one of the variables. And like I said with the substitution video, is what's cool about these systems problems is that you're free to do the problems anyway. So elimination, substitution, graphing, all of them work on all the types of problems. It's just a matter of preference what you like to use. And also sometimes the problems are set up to be solved simply using one of the methods. So this first example we're going to look at is actually a really easy example to solve with elimination. And then we'll show you another one where it's not quite as straightforward. So here's how my elimination process works. What I want to do is I want to literally add the two equations together. And so what I'll do is I'll do a plus, and I'll draw my line like I'm adding, and then I'll go add these vertically. Now notice I do have columns, that's going to be important. So I have a column of x's, a column of y's, and then my constants over there. So you do want to make sure that that is in place before you add the equations together. So I'll go ahead and do that. X plus x gives me 2x. 2y plus negative 2y actually cancels out. It's eliminated. That's why I call this the elimination method. The y's are gone. And then again add everything, so equals 8. And look at that, just like that I'm down to now just one equation with one variable which I can solve. So I'll divide both sides by 2 and there's my first answer, just like that, x is equal to 4. Well, remember though, you're not done because every x needs a y and every y needs an x. So to find your other variable, just like with substitution, go back to the beginning and plug that value in and solve for the other variable. You're welcome to use either equation, the top or the bottom one, it won't matter. So pick the one that's easier, which one you like better. The top one is no negatives and smaller numbers, so I'm going to pick that one. So let's replace our x with 4, and then solve for y. So why do I keep saying 2? 4 plus 2y is equal to 2, because there's so many 2's in this problem. I'm going to subtract 4 from both sides, so I get 2y equals negative 2. There's those 2's again. And then divide both sides by 2, so I get y equals negative 1 when I do that. If you can do that, again, like I said in the substitution video, that's great. Ideally, though, I want a coordinate, because that's what this point really is. That's what these numbers represent. They're the intersection if I were to graph these two lines. So 4, negative 1 is going to be my solution to this system. I could plug both of those in to check it. If I wanted to, they will both work out. So that's elimination, and I did pick a very easy one to start with. Let's take a look at what happens, though, in this case, one that's not so easy to solve with elimination, or not at least that easy. So let me go ahead and just kind of start the same way I did last time. So I'm going to add the two equations together, and I add this up, and I get 9x minus 15y, and then equals 18. And so let's see what happened there, because last time one of the variables got eliminated and I was able to solve it. This time I did not eliminate any of my variables. I still have an x and a y. So in fact, this is no good. I can't just add the two equations together this time. Instead, what I'll need to do, and what I'm allowed to do, is I can multiply an equation by a number first. And I can actually multiply both equations by different numbers if I want to, in order for elimination to work out. So what I'm going to do is I'm actually going to put parentheses. Oops, let's get a color first. I'm going to put parentheses around this entire top equation, which is really bad notation, but I'm going to do it anyway. And I'm going to multiply the equation by negative 2. Some of you may have no idea why I'm doing this, or where that negative 2 came from. And I'm going to tell you, it didn't really come from anywhere. I'm just kind of thinking ahead, and if you don't see where it came from, just kind of watch and see what's going to happen. So let me multiply everything in that top equation by negative 2, and I'm going to write that below the other one and just kind of watch and see what happens. So negative 2 times 3x is negative 6x, and then negative 2 times negative 7y is positive 14y. And then also multiply the 10 by negative 2 equals negative 20. And if you look at what we have now do you see why I picked negative 2? Now when I go to do elimination, the x's will drop out. 6x minus 6x is 0. That's why I chose negative 2. You kind of have to do some forwards thinking in these problems and think, what could I multiply one equation by to end up with opposites so they would be eliminated? So that's kind of the tough part with this, thinking ahead and thinking what would multiply. Sometimes even it's going to take multiplying both equations by a number. Sometimes I may have to multiply the second equation by something as well to get opposites, and if that's the case, then so be it. But anyways, let's go ahead and finish this problem using this method. So negative 8y plus 14y leaves me with 6y, because my x's have been eliminated. And then add these together too, I get negative 12. And now elimination doesn't work. Look at that, I only have one variable. So I can go ahead and divide and get y equals negative 2. Oops, I forgot my negative. negative sign, y equals -2, and then don't forget though, you're not done. Every y needs an x, every x needs a y. So go back to the beginning with this, either equation, the top one or the bottom one, I'll just pick the top one I suppose, and plug your value back in and find your second variable. So I'm going to rewrite 3x minus 7 times, I know y is -2, so I'm going to plug that in, and then equal to 10. And let's solve from there. So 3x plus 14 would equal 10. I'll add, or subtract 14 from both sides, sorry. So I subtract 14 and get -4. And I divide this and it looks like I have a fraction, which, so be it, that can happen. So x must be -4/3. And again, ideally, what I want you to do is write that as a coordinate. So x comes first, even though we found it second. So in parentheses, I've got -4/3, comma -2 as the solution to this system.